Nonlinear Principal Components Analysis, NLPCA. If the bottleneck neural network is trained as an identity map, that is with outputs equal to inputs, and using a mean square error objective function, then the neural network can be viewed as performing nonlinear principal components analysis, NLPCA, Kramer, 1991. Since the final NN outputs are created from the internal NN representations at the bottleneck layer, the bottleneck outputs can be viewed as the reduced dimensionality version of the data. This idea was tested using pseudorandom data generated so as to cluster on curved subspaces. NLPCA is first illustrated by an example depicted in. For this case, 2D pseudo-random data was created to lie along a U-shaped curve, similar to the data depicted in. A neural network, 25152, was then trained as an identify map. The numbers in parentheses refer to the number of nodes at each layer, proceeding from input to output. All hidden nodes and output nodes had a bipolar sigmoidal activation function. After training with backpropagation, all data were transformed by the neural network. In, the original data is shown as blue symbols, and the transformed data is shown by red. Clearly, the data have been projected to a curved U-shaped line, as would be expected for the best line fit to the original data. Plot of input and output data for pseudorandom 2D data. The output data, red line, is reconstructed data obtained after passing the input data through the trained neural network. In, NLPCA is illustrated by data which falls on a 2D surface embedded in a 3D space. For this case, 2D data pseudo-random data are created, but confined to lie on the surface of a 2D Gaussian-shaped surface, as depicted in the left panel of. Then a neural network, 310-210-3, was trained as an identity map. After training, the outputs of the neural network are plotted in the right panel of. Clearly the neural network learned a 2D internal representation, at the bottleneck layer, from which it could reconstruct the original data. Input and output plot of the 3D Gaussian before, left, and after, right, using neural network for NLPCA.